5.1 function composition. Definition. We say the composite function f composed with g is f of g of x, where x is in the domain of g x is in the domain of g, and g of x is in the domain of f. So we have x going into the function g, and what comes out is g of x, which goes into f, another function, and the outcome is the composition f of g. Example, f of x is 2x minus 5, g of x is x squared minus 3x plus 8. A, find the composition of f and g of x. So by definition, this is f of g of x, and we substitute first the inside function, so that's g, x squared minus 3x plus 8. And now we look at f, and what f does, if you give it x, it does 2x minus 5. So instead of x, we're going to put the input x squared minus 3x plus 8. And then we have minus 5. We simplify. And we have 2x squared minus 6x plus 16 minus 5. Like terms, 2x squared minus 6x plus 11. So that's our new function, f of g of x. So now we're going to find g of f. So the order is important by definition. This is g of f of x. We substitute the inside function first, which is f, and f is 2x minus 5. So now we look at g, and instead of x, we're going to have 2x minus 5. So that is squared minus 3 times, instead of x, 2x minus 5. And finally, plus 8. So after we simplify this, we should get 4x squared minus 26x plus 48. So you should go ahead and FOIL, combine like terms, and see if you get this. 4x squared minus 26x plus 48. Part B, the same example with the same functions. We want to figure out what is f of g of 7. So we already have the equation of the composition of f and g. It's this one. So all we have to do is plug in 7. 2 times 7 squared minus 6 times 7 plus 11. So 2 times 49 minus 42 plus 11. And that should be 67. Now, the composition of g and f of 7. 4 times 7 squared minus 26 times 7 plus 48, and that is 62. Part C, find the composition of g with g of 1. So by definition, this is g of 1. So we calculate the inside first. So that is g of, let's see what is g of 1. G of 1 is, we can calculate it separately right here. So g of 1 is 1 minus 3 plus 8. So that is negative 2 plus 8, or 6. So we plug this in here, and we have g of 6. So g of 6 is here's g, x squared minus 3x. So 6 squared minus 3 times 6 plus 8. So that is 36 minus 18 plus 8, which is 36 minus 10, so 26. So 26 for part C. And one more example, D, calculate the composition of f and f of x. So by definition, this is f of x, and we already have f of x, and that was 2x minus 5. So now we look at the f, which is 2x minus 5, and instead of x, we put 2x minus 5. And we simplify 4x minus 10 minus 5, so 4x minus 15. Another example, f of x is square root of x, g of x is x minus 3. A, find f composition with g. By definition, this is f of g of x, which is f of x minus 3. So we substitute g first, right here. And now we look at f. What f does, just take square root of the input, so that would be square root of x minus 3. And we're done. Now let's calculate g of f of x. So the order is important. By definition, this is g of f of x. We substitute f first, so that's square root of x. We look at g. What g does, you take the input and subtract 3. So completely different functions. So B, find the domain of the composition. Find the domain of f compose g. So we have the equation, and that is square root of x minus 3 for the previous example A. So we have to make sure what's under the square root is greater or equal than 0, which is x greater or equal than 3. So the domain is OX such that x is greater or equal than 3. Then find the domain of the composition of g and f, which was g of f of x, and we already calculated it. The domain of f is x greater or equal than 0, because f of x was the square root of x. All right, so one more example. We have f of x equals 1 over x minus 2, and g of x equals 5 over x. Both of them are rational. Find the composition of f and g of f and their domain. So first, composition of f and g is f of g of x. So substitute the inside, which is g, 5 over x. And now substitute 5 over x for x in f. So it'll be 1 over 5 over x minus 2. Now we need to simplify this. I mean, we don't have to, but we could. We can leave it like this. And the domain, OX, except we have to simplify it to find the domain. So let's do this. 1 over 5 over x minus 2x over x, so they have the same denominator. 5 minus 2x over x multiplied by x, top and bottom, So it's x over 5 minus 2x after these two cancel. So now in the domain, we have to say OX such that the denominator is not 0, which is 5 over 2. And now the composition of g and f, that will be g of f of x, which is g of 1 over x minus 2. So now we look at g, and we have 5 over, instead of x, 1 over x minus 2, and simplify it. So I'm going to multiply by x minus 2, top and bottom. And these two will cancel. So we have 5 times x minus 2. So the domain will be OX such that x not equal to 2. Even though the final function is linear, we did have x minus 2 in the denominator, so we have to exclude it. All right, and that concludes the lecture for 5.1.